Today we will look into transformations of linear functions. Earlier we have learned linear functions as y is equal to mx plus b form. In some resources you will see linear equations as y is equal to ax plus b. There's no difference between the two. We will graph linear equations by using transformations to a parent function. A parent function is the very basic form of that function. In this case, we are working with linear functions, and the very basic form of linear function is going to be y is equal to x. We will take the parent function of y is equal to x, and we will do transformations to it to get new functions. And while we are getting the new functions, we will eventually obtain new a values and b values. A values will tell us to vertically stretch, compress, and or flip the line. B values will tell us to translate, shift the graph either up or down. Let's look into a vertical translation. And in this process, we will take the parent function y is equal to x. This is our y is equal to x. And we will translate it. Translation is the process. We will translate it 2 units up. So take the parent function and translate it 2 units up without changing its direction or slope. We will just slide it up 2 units. That's how we will do vertical translation. Next thing we will do is to look at the a value in y is equal to ax plus b. Earlier, on the previous slide, we saw that b showed us to slide the graph up or down. A value now is going to tell us whether to flip the line over the x-axis or not. A value will also give us information about stretching and compressing. When a value is less than 0, meaning negative, that means we would need to reflect the parent function over x-axis. When our parent function is y is equal to x, we will take the parent function and reflect each point over x-axis to find the new line, new equation. Y is equal to negative x will be the equation of the reflected line. And a value in here is negative 1. A is equal to negative 1, indicating that this graph, y is equal to negative x, is a graph of parent function after it's been reflected over x-axis. Now let's combine a reflection and translation together. Let's say that we have a question y is equal to negative x plus 2. That means we will have to take the parent function, reflect it over the x-axis. After our reflection, we are going to translate it 2 units up. As you can see, each point has been translated 2 units up. And our final equation is y is equal to negative x plus 2 is the equation of this blue line. Now, let's look into vertical stretch and compression. A vertical stretch happens when the a value, absolute value of a value, is greater than 1 in y is equal to ax plus b. When a is greater than 1, when compared to parent function, you will have a bigger slope. Bigger slope is going to create a steeper line. Vertical compression, on the other hand, will have an absolute value of a that's less than 1. It's going to be a fraction. When it's less than 1, when compared to the parent function, we will have a smaller slope. Smaller slope will give us a less steep line. For each of them, We call them vertical compression and vertical stretch, because in the parent function we have 1 goes to 1, 2, 2, 3 goes to 3, 4 goes to 4. In vertical compression, 1 goes to 2, 2 goes to 4, 3 goes to 6, and so forth. As you can see, each point is being stretched vertically. Likewise, on the vertical compression, originally we would go 1, 1, 2, 2, 3, 3, when x is 4, y is 4, but on the vertical compression, when x is 1, y is half, x is 2, y is 1, 1.5, 2. So each of the y values are being vertically compressed. That's why we call them vertical stretch and vertical compression. I put absolute value of a in here because we need to use the negative for the reflection of x-axis, and we will only look at the number when we are determining vertical stretch and compression. Here's an example. I have the parent function already given. Now I will find vertical stretch by 3. I will have the same origin. This time my slope is going to be 3. All I need to do is to connect this line, and this is the y is equal to 3x line. Here's one for you to try. Determine whether you need to do vertical stretch or compression. Here's another example. We have the parent function. We will first stretch the parent function for 2. Then we will take the stretched function and move it up 3 units. This is how we can create the equation for y is equal to x plus 3. So take the parent function stretched by 2 and then shift it up 3 units. And here's one for you to try. That's pretty much it. In the class we will go into a little bit more detail.